Next point is derivative of quotient. If u and v are differentiable functions of x and y equal to u upon v, then prove that dy by dx is equal to v du by dx minus u dv by dx upon v square not equal to 0. That means what is the meaning of this total term? When we take derivative of quotient, dy by dx is equal to in between u and v, right? First v, take derivative of u, minus write u, take derivative of v and take v square. This is the meaning. Take v first, take derivative of u, du by dx, take minus sign u, take derivative of v, dv by dx upon v square while solving the questions. Now proof of this: y equal to u upon v, add small increments, y plus delta y, u plus delta u, v plus delta v, delta y is equal to u plus delta u, v plus delta v, y to this side minus y. Delta y is equal to, right here, that is delta y is equal to u plus delta u, v plus delta v minus, put value of y is u upon v. Is equal to, take cross product, v u plus delta u minus u v plus delta v upon v into v plus delta v is equal to, multiply inside uv plus v delta u, v delta u minus sign as it is, multiply inside by uv plus u delta v upon, multiply inside by v square plus v delta v minus, multiply only by uv plus u delta v square, v delta v. Next step is equal to uv plus v delta u, sign change inside, minus uv minus u delta v upon v square plus v delta v. Term get cancelled. V delta u delta v square plus v delta v delta y. Next step, dividing by delta x. Therefore, delta y by delta x is equal to v delta u delta v divided by delta x, and this term as it is, dividing by delta x to both the sides. Here dividing by delta x, here at this term divide by delta x and write this term as it is. Next step, that is delta y by delta x is equal to phi delta u minus u delta v. Take this delta x here, divide by b square plus v delta v. Next step is this term. Now take this term here, this term as it is at the denominator. Next step is equal to phi delta u divided by this term delta x minus. Now here are two terms, there is difference, and here is this denominator. We here there are two terms, there is difference, and this is division, this is denominator. We take this denominator to every term as phi delta u upon delta x minus u. Write this phi separate, just separate. Phi delta u by delta x minus u delta v by delta x at the denominator, v square plus phi delta v phi this denominator minus u this denominator, this term as it is. Taking limit as delta x tends to 0, therefore limit as delta x tends to 0, delta y by delta x is equal to phi limit as delta x tends to 0, delta u by delta x. I have cleaned that step. Here was that step. So look at this step. Look at this step. We do next step here. Delta y by delta x is equal to phi delta u by delta x minus u delta v by delta x. P square plus phi delta v, p square plus phi delta v, and here we have to take limit, taking limit as delta x tends to 0 of both sides. Taking limit as delta x tends to 0 of both sides. So take limit of this step. x tends to 0, delta y by delta x is equal to phi limit as delta x tends to 0, delta u by delta x minus u limit as delta x tends to 0, delta v by delta x at the denominator. V square, thus phi limit as delta x tends to 0 of delta v, delta x tends to 0 of delta v. Value of this term, that means limit as delta x tends to 0 of delta v is always 0. Delta x tends to 0 of delta v is 0. So 0 into v is 0. That means this total term is 0. Total term is 0. Therefore, we on next term is only next step. We have only is this side as it is, this numerator as it is, and this value 0. So v square only here. Next step is this step. If we see then u and v are differentiable functions of x, therefore limit as delta x tends to 0, delta y by delta x is dy by dx. Phi u and v are differentiable functions of x, therefore limit as delta x tends to 0, delta u upon delta x is du by dx minus u, this value is dv by dx upon v square. Limit as delta x tends to 0, delta u upon delta x is du by dx. Similarly, this value is dv by dx. So, limits at RHS and LHS exist right here. Since limits at RHS and LHS exists, this step we write from this step, we write this step from this step, since limits at RHS and LHS exists. And in this way we prove this quotient rule. Dy by dx is equal to phi du by dx minus u dv by dx upon v square. This we prove here. U dv by dx, u dv by dx upon v square. So, when there is a ratio of two functions and we want to take derivative, take numerator phi u, denominator phi, and remember this formula: phi take derivative of u minus u take derivative of phi upon v square. Phi du by dx minus u dv by dx upon v square. Dy by dx is equal to phi du by dx minus u dv by dx upon v square. Quotient rule, remember, when there is division of two functions, numerator take function u, denominator take function v, put here proper, that that means u, v properly, right, and take derivatives respectively. Derivative of u and derivative of v and all that. And next point, the derivatives of functions, actual formulae.